Hello, learners. Welcome to the second session of prompt engineering. So, today we are going to study the techniques for clear and specific prompt creation. So, as a learning objective, we are going to familiarize with advanced techniques like zero shot learning, few shot, and chain of thought prompting. So, these are few techniques which we are going to study today. That how you can better give the prompt or the instruction to your AI model. We'll also be understanding the role of self-consistency and knowledge generation in enhancing the AI responses. We will be exploring the concept of directional stimulus prompting to guide your AI towards the specific outcomes. So let's start. So prompt engineering is a powerful tool we have seen. But if I just add these advanced techniques in my instruction, which I'm giving to my AI model, then I can get a more better performance or some improved result for many of the complex tasks. So these are some techniques which we are going to discuss today. One is zero shot prompt, few shot prompt, chain of thoughts, that is commonly known as COT prompting. You could have self consistency, you could have knowledge generation prompting, then we have directional stimulus prompting. So we'll be looking at all these techniques today. So let's start with zero shot prompting. So this is like giving your AI a direct order without any examples. It's like saying, write me a poem about the ocean. The AI has to generate the poem based on its existing knowledge. Okay, so that is just simple example. So we'll look at the definition. Zero shot prompting means that the prompt used to interact with the model won't contain any example or the demonstration. The zero shot prompt directly instruct the model to perform a task without any additional examples or instances. Okay, so you're directly asking without mentioning any kind of example, and your model will generate the answer based on the previous knowledge it has. So let's say classify the text into neutral, negative, and positive. The text is, I think the vacation is okay. Now classify the sentiment of it. The output is neutral. So it has given you the right output because based on its previous knowledge, it can answer that. Now, but there are some certain tasks which doesn't work without giving an example. Okay. So now what that happens? What is that kind of task? So next we have the few shot learning. This involving few examples to guide your AI model. It's like showing the AI few different poems. Let's take the same example as we have taken, that write a poem on the ocean for me. Okay. So that is about the case which we have taken in zero shot learning. Now, based on the previous knowledge, earlier it was giving you the answer. Now, if I just provide certain set of poems to it and then ask my AI model, now based on these kind of poems, or write a new poem for me. So that means I have demonstrated few examples to it. So that is few shot prompting. So few shot prompting enables in context learning where we provide demonstrations in the prompt to steer the model for better performances. The demonstrations serve as a condition for your examples where we would like a model to generate your responses. Let's try to understand it with example. So the prompt you have given is positive, this is awesome. This is bad, negative. So even you have not maintained the structure properly, but it has got the gist that what you are talking about. So this is awesome is a positive sentence. This is bad is a negative sentence. Wow, that movie was great. So that is a positive sentence. What a horrible show. Okay. So what a horrible show, that means you need to ask the answer for this. Okay. So whether it was a negative one. So based on all these sentences or text you have provided as a set of example, even if they are not structured well enough, because you have seen that here the sentiment was given in at the starting, here the sentiment was given as at the end, and it is in the next line. So it was not properly structured. But even though your network was able to analyze the prompt because you have provided certain, you have demonstrated certain set of examples to it before just asking to it. So that is few shot prompting. The next is chain of thought prompting. So what happens in chain of thought prompting is particularly useful for complex tasks that require some reasoning. Okay. So we guide our AI model to think step by step, like you're breaking down a mathematical problem into the smaller parts. Now let's try to understand the definition. So chain of thought prompting enables complex reasoning capabilities through intermediate reasoning steps. So if I have to calculate the something, then I have to follow the steps of something. Okay, so this is how the chain of thought works. It provides the intermediate reasoning steps to do that task. You can also combine it with any of the other few shot prompting to get the better result for any more complex task that require reasoning before responding. Okay, because your AI model doesn't know everything. If you provide certain examples which are related to it, then it can better understand your problem and give you the answer with more reasoning steps. Okay, so let's try to understand this chain of thought concept with this prompt. So here the prompt which you have given is the odd numbers in this group add up to an even number. Okay, so I want the answer for this. So first step should be that I need to find all the odd numbers. So first step I have given that adding the odd numbers. So I have find it out the odd number, and that instruction I have mentioned here. Okay, the answer is false. So one example I have given, and the step I have also mentioned, that first I have added all the odd numbers, and odd number in this sequence was 9, 15 and 1. Then I have given the added form was 25. Then I have also given the answer that it is not an even number. So that is a false. Okay. Now, based on this example and step-by-step reasoning of this question, I have asked the similar question. The odd number in this group, add them up to an even number. So you have given the sequence of odd numbers. Now your model understands how to respond to this particular question because it was well demonstrated before. Now the output is adding all the odd numbers, that was 15, 5, 13, 7 and 1 in this group of numbers, and when I just add them up it gives 41, and this is not an even, so the answer is false. So this is the chain of thought prompting. So let's say you can combine also this. Okay, you can also combine this chain of thought prompting with either few shot prompting or zero shot prompting. Okay, so this was the few shot prompting. If I directly ask the question with an example, it is possible that it would give you the correct answer. But if I ask the same question with giving the step-by-step reasoning to it, I can use in combination with few shot learning, I can combine the chain of thought prompting, then you see it has given you the correct result actually, because now it has break down your problem into each steps, and with those steps it has responded, and now it has responded you the correct answer. Okay, you can also combine it with zero shot learning. Now you have this question that zero shot learning, it doesn't give any example, it doesn't give any demonstration, but that is also possible with zero shot learning, that you are combining the zero shot learning with chain of thoughts prompting. And how you will combine this? You just need to ask, let's think step by step. So your model will first look into this part, then it will look to the next question part, then it will look into the next question part. So it will break down your concept of question into the steps, and for each step it will respond accordingly. So that is an example. So I'm using the chain of thought with zero shot learning. So I can just write it as an instruction that let's think step by step. So this was the question. So first step was this, you started with 10 apples. The second was this, you gave away 2 apples to the neighbor, 2 apples to the repairman. So you had 6 apples left. Then you bought 5 more apples. So now you had 11 apples. Finally, you ate 1 apple. So you would remain with 10 apples. So it has got a proper instruction that how to think about this problem. You have given think about it problem step by step. So it has provided you answers step by step, and that is how it has improved the performance and giving you the correct answer. Then you have self-consistency. Now, what is self-consistency? Self-consistency is a technique where we ask our AI to solve the problem in multiple ways. By comparing different solutions, we can identify the most reliable one. Okay, now try to understand this. It is the idea to sample multiple and diverse reasoning paths through few shot COT and use the generation to select the most consistent answer. This helps to boost the performance of your COT prompting on tasks involving arithmetic or common sense reasoning. Okay, so let's take in prompt like when I was 6, my sister was half of my age. Now I'm 70. How old is my sister? So when the person was 6, his sister was 3. And now what this prompt is doing? When he was 70, his sister is still 35. This is a wrong answer, right? Now what happened? If I use the self-consistency method, I just improve this prompt. Now I give many set of examples, like they are not exactly same as you are asking the question with this instruction, but they are give you a similar kind of examples that you'll get in logic that how to solve these kind of reasoning questions. So there are 15 trees in the group. Group worker will plant trees in the group today. After they are done, there will be 21 trees. How many trees did the group worker plant today? So we started with 15. Later we have 21. The difference must be the number of trees they planted. So they must have planted 6 trees. So the answer is 6 trees. Okay. So you have provided the logical reasoning, step by step solution to it. Okay, and you have given many such, and it will try to find out which is more relevant to its task. Now you are asking the question for the same question. When you give this prompt, now it will answer in this way. When I was 6, my sister was half of my age, so she was 3. Now I am 70, so she is 70 minus 3, that is 67. So the answer is 67. Now it is an correct answer. Okay, so this is how you could use self-consistency when you're using the prompt as your instruction. Now the next one is what? The next one is generate knowledge prompting. So knowledge generation involves providing the AI with additional knowledge. So you are providing some additional knowledge, a set of knowledge that might be helpful for that task. It's like giving the AI access to your textbook before asking it to write an essay on it. Okay. So that is the generation of knowledge prompting. So let's look at its definition. This technique involves using additional knowledge provided as part of the context to improve result on complex tasks such as common sense reasoning. The knowledge used in context is generated by a model and used in the prompt to make a prediction, and highest confidence prediction will be used later, okay, as an answer. So that is the generate knowledge prompting. Okay, so that was the definition. If you have not understood till now, no problem, we'll try to understand it with an example. Okay, so let's say I have given this whole set of input. I have talked about Greece is larger than Mexico. Okay. So if I'm asking a question about Greece and about its area, then you have also provided a complete set of textbook to it about that Greece, that what is there in the Greece, what is the temperature, how many kilometers they are from Mexico, and all the whole set of knowledge I have provided about that. So that is generate knowledge prompting. Okay. So if I want any knowledge out of this text, I can ask a question in that format and it will provide me based on its previous all knowledges. So that is generate knowledge prompting. So whatever knowledge is at higher confidence, it will provide you that as an answer. The last one is directional stimulus prompting. So we have finally directional stimulus prompting. This is a way of fine tuning your AI responses by providing hints or the keywords. It's like giving the AI a nudge in the right direction. So where you have to think. Okay. So you're also giving some keywords. So let's say if you have played a Damsharas kind of a game in which if I have to recognize the movie name, so you are giving a certain keywords about those, like when you provide certain keywords and your team is going to recognize those keywords, you'll able to interpret that what movie that was. Okay, so in the same way, for the directional stimulus prompting, you are providing certain keywords so that your model will move into the hint or the keyword, so that your model will move into the right direction to give you a better response or improved response. So it is a prompting technique to better guide your large language models in generating the desired summary. The tunable policy of large model is trained to generate the hints that a guide a black box frozen LLM. So we don't know that how LLM works, and you don't even need to know if you're just using these tools. Okay, so when you're just using this tool, you don't need to know that how these language models have been trained on and everything. Okay, but you should know that how to use effectively these models. Okay, so to effectively use this model, one of the approach, directional stimulus prompting, we are using, which uses what? Which uses hints or the keywords that will move your language model to think in a right direction before giving you certain output. Okay, so let's say you are given with an article. Okay, and in this article I want to focus on this thing: the price is right, Bob Barker, 2007. So this was my citation in this article. So I want to get a focus or the keyword to get an answer on this. Okay, so it has got the highest confidence. Okay, and now with that, in the summary part, it has included those keywords because I want my answer to include those keywords and to be around, and summarized my context to be around those keywords. So that is the directional stimulus prompting. So let's try to understand with this example you are given within this article. Okay, now standard prompting is summarize the above article briefly in 2 to 3 sentences. Okay, so it has summarized in a random way. But if you have given the prompt that summarize the above article briefly in 2 3 sentences based on the hint, and hint you have given that you have to focus on this person, the Bob Barker, and what the price is right, what was the work of this person, okay, in what year it was. So based on this hint, the answer, look at the difference in this example. Now it is given on April 1, Bob Barker returned to the TV show The Price is Right. So what was the show? The Price is Right. After 8 years, looking spry at 91, Barker handled the first prize guessing game. Barker stepped down as host in 2007 but didn't seem to miss a beat. Okay, so this whole context was revolving around Bob Barker. Okay, so when you have provided the hint, it has given you the right context using those hints with your improved answer. Okay, so that is the difference you are making in your prompt engineering by using these advanced techniques. Now, as a summary, we have learned some useful techniques that you could apply when you are giving instructions to your AI model. These are zero shot prompting, that means direct instruction without example. Next is few shot prompting, that provides example to condition the AI. Then you have COT prompting, that uses reasoning step for complex task. Then you have enhancement. In these techniques only, one is self-consistency, that boosts your reasoning reliability by aggregating the multiple paths. Knowledge generation incorporates additional context to improve your outcomes, and directional stimulus prompting fine-tunes the response for better control over the responses. So this was all about your today's session. I hope you enjoyed the session. Happy learning.